Yes, good morning, one and all. This is Ravi Kumar TR, Assistant Professor from Mechanical Department. So, last class we discussed about orthographic projection of planes, and also we discussed about what are planes. That object can be represented by two-dimensional nature, and types of planes. There are two types of plane. One is a regular plane, and another one is irregular plane. Then parts are nomenclature of planes, the corners and the edges are sides. How do you project a plane? First you project the corner of the each plane, then join all the corners of the plane on the plane of projection, then you get a projected plane. Then you know the different position of plane. The plane is one is parallel to one plane and perpendicular to another plane, and the lamina is another one is inclined to one plane and perpendicular to another plane and inclined to both the planes. Then true shape and apparent shape. As you know that the actual lamina, when the projected lamina is equal to the actual lamina, then is called the true shape. When the projected plane is not equal, not actual shape to the projected lamina is not in the shape of the projected lamina not equal to that actual shape, then is called the apparent shape of the lamina. Today we are going to solve some basic problem related to the laminas. The first problem is a regular triangular lamina of sides of the lamina is 30 mm. The lamina is parallel to HP and perpendicular to VP, and one of its side is parallel to HP and perpendicular to VP. Draw its projections. So first read the problem one or two times, carefully understand it, then write the given datas. Now what are the given datas? First identify the type of lamina is given. What is the type of lamina? It's a regular triangular lamina. The lamina is regular triangular. The regular triangular lamina. Regular triangular lamina means regular means all sides are equal. What type of shape of the lamina is triangular? Is a triangular lamina of this is a triangular lamina, and side is given. How much side it is? Side is 30 mm, means all sides are equal, and the condition is given. What is the condition? The lamina is parallel to HP and perpendicular to VP. The lamina is parallel to HP and perpendicular to VP. And one more condition is that one of its side is parallel to HP and perpendicular to VP. Then draw its projection. Now this is the basic the problem, and after once you read the problem one or two times, then you go for it the given data. Now take the lamina is a regular triangular lamina, is a equilateral triangle. Okay, the side, the corners A, B, C, AB, BC and C are the sides or edges. Now this is what we called as a plane. One is horizontal plane and vertical plane. They are right angle to each other. On horizontal plane, as you know that top will come. On vertical plane, as you know that front will come. The intersection of the horizontal plane and vertical plane is the intersection line is called as XY line. Now go for actual problem. Now the lamina is, if you the first, what is the lamina is? Triangular lamina of size 30 mm. All sides are equal. Now the lamina is parallel to HP. If you place the lamina is parallel to HP. Now this is lamina is parallel to HP, and if you project it, all the how do you say lamina is parallel to HP means, if you place the lamina like this, the corner ABC is equidistant from that plane, then you call it the lamina is parallel to HP. Perpendicular to VP. Now if you project all the corners on the plane, if you project all the corners on the plane, that lies on a what? Straight line, a straight path. Then you say that the lamina is perpendicular to that plane, right? Now if we place like this, now this condition, first condition satisfied, that lamina is parallel to HP and perpendicular to VP. But one more condition is given. What is the condition? One of its side is parallel to HP and perpendicular to VP. If you position like this, no, all the sides are parallel to HP only, but is no one side is perpendicular to VP. Then what I will do, I will go for rotate lamina like this. Now you can see that the side AB is parallel to HP and perpendicular to VP. Means, how do you say perpendicular to VP? Means the corner B and A is coincide and make a one point. As you remember, the orthographic projection of lights is similar to same thing, right? Now this is the first condition. This is what is, the plane is parallel to HP, perpendicular to VP, and one of its side is parallel to HP, that is side AB, and perpendicular to VP. Then we will go for project it on the two-dimensional plane. This is actually is a three-dimensional one. How do you make two-dimensional? By rotating horizontal plane, by rotating the horizontal plane by 90 degree. Now you can see that now this is now XY line, above XY line is VP, this below XY line is HP. On HP top will come, on VP front view will come. Now how do you construct it on two-dimensional plane? Now how do you construct it on a two-dimensional plane? First draw a line, horizontal line, that line is called as XY. As you know that all the planes will come under first quadrant only. And one more thing is, you can see the condition of the lamina is parallel to HP, perpendicular means the lamina comes in the first position. Lamina is parallel to one plane and perpendicular to another plane. Parallel to one plane and perpendicular to another plane. Now first draw a horizontal line. Draw a horizontal line and name it as, above the horizontal line is VP, below horizontal line is HP. And horizontal plane which we will come front view, below horizontal line which will come top view, right? Now first construct a regular lamina. As you know that triangular lamina, as you know that how do you construct the triangular lamina, we already discussed in the first class, right? First draw a vertical line of side how much, 30 mm, the side is given 30 mm. Now called as on top view, how do you look at nomenclature? It is the corner is with the lowercase letter A, B, right? Now through the how do you construct the triangle line? Through the compass, take B as a center, BA is the radius, and draw an arc. Then A is the center, AB is a radius, and draw one more arc. The intersection of the arc, that point we called as C. Either go for arc method, is a very easiest to construct. Now we'll get this lamina is parallel to HP, means you'll get the true shape of this lamina. I mean, whatever the actual lamina is there, once you projected the lamina, the projected lamina is actual shape and actual size. It is called as a true shape. Now we'll get the top view. Then how do you get the front view? First to project all the corners. Now you can take any convenient distance, is not given here, any convenient distance you can take it. Now from all the corners, from corner A you draw a vertical projector, from B also, B and A is coincide, draw vertical projector, from the corner C also you draw a vertical projector. Take any convenient distance. Now from corner A, this is A dash, from B and A is coincide, right, B dash, but from when we view from this side, B corner B is visible, but A is invisible. That's why B dash is visible, A dash is invisible. What about C is dash is visible. Take convenient distance, then join those corners, now you can get the lamina is parallel to HP and perpendicular to VP. On second condition, one of its sides of the lamina is parallel to HP and perpendicular to VP. This is how do you project the lamina on horizontal plane and vertical plane. Now then, how do you construct the side view? As you know that, how do you construct? Already you know that in orthographic position of lines, draw one more line. That line is called as x1 y1. The intersection of xy and x1 y1, that intersection point is called as O. Now how do you project the side view? How do you get the side view? Always you draw a mediator line always beside the horizontal plane. How do you know draw the mediator line? By drawing a 45 degree with respect to a xy line. That line is called as what? Mediator line. Now we'll project from the top viewpoints. Draw horizontal projection from corner A. Draw a horizontal projection. There should be a thin line that we call as M suffix A. From B also draw a horizontal projector. That point is called M suffix B. From corner C also draw a horizontal projector. That point is called M suffix C. From the MA, draw a vertical projectors from MB, MA, and also MC. Now from the front view, from A dash, draw a horizontal projector. A dash, MA, that coincide, that will get A double dash. Similarly, B dash, horizontal projector, MB, vertical projector, that will get B double dash. From C dash, horizontal projector, from MC, vertical projector, then you will get C double dash. Then join A dash, A double dash, B double dash.